Morning students. Today in this class we are going to discuss in detail about a direct memory access. Direct memory access means from the name you understand that we are accessing the contents directly from the memory, so it will be automatically faster. So what is the purpose of direct memory access is to transfer large amount of data at high speed between the external devices and the main memory. DMA approach is often used for faster transfer. So DMA controller allows the transfer directly between the input device and the memory with the minimum intervention of the processor. That means without any disturbance, without any intervention, the data is transferred continuously. The DMA controller acts as a processor, but it is controlled by the CPU. So DMA controller is also like a mini processor. It initiates the transfer of a block of words. The processor sends the following data to the controller. The starting address of the memory block, the word count control, whether to read or write, what process you want to do, and a control to start the DMA transfer. Here there are various three important signal: status and control signal, interrupt request signal, interrupt enable, read, write, or done. So here we are having 32 bit to represent the status and the control, 0 to 31. The bit ranges from 0 to 31. The starting address is represented, word count is also represented here. The flags that is available here are read flag or write flag, read or write anyone. Then again done, data transfer finishes, then interrupt request enable, and interrupt enable raises the interrupt after the data transfer. So this is actually the use of a DMA controller in a computer system. In a computer system, we are having the memory processor, then it is all connected with the DMA system bus. Here we are having disk or a DMA controller that is used for transferring the data from the hard disk to the main memory. Hard disk to the processor we are doing. So the DMA controller here, it is connected with the network interface like a bus or card or any communication interface is used here. Then the printer or the keyboard that is used for output. So the DMA controller is connected like a processor to the computer system via the system bus. Now this is a flowchart representing the DMA for the disk transfer. So here what we are doing is enter to transfer, that is the status, whether to read or write we have to enter with the word counter and we have to start the process. Then here the central process unit sets up a disk for DMA controller. Then the DMA device begins the transfer independent of CPU. Now the CPU does not involve. It gives the control to the processor. What the processor will give the control to the DMA controller, and the processor is not involved here. So the processor is dedicated some other work. So thereby we are increasing the multiprocessor capability via DMA, direct memory access. Device begins to transfer independent of the CPU. CPU executes another process. That's what the CPU is involved in some other process. DMA is used for transferring the data. So it will continue till the last word is reached here. Now here what are the various types of DMA transfer? Are block DMA transfer, cycle transfer, and transfer. In block DMA transfer, it supports fastest IO data transfer rates. It makes the CPU inactive for a long period. So block transfer is used for huge. From the name you understand block. Then cycle steal means method that is alternative to the first method is called as cycle stealing. It allows DMA controller to use the system bus to transfer one word after it must return control to the bus of the CPU. So one by one cycle it is transferred, not like a block transfer. This is a cycle stealing. Cycle still reduces maximum IO transfer rate and allows and also it reduces the interface of the DMA control and the CPU memory access. So the second type is called as what is cycle steal DMA. Then the third type is called as transparent DMA. It is possible to eliminate the interference completely by designing the DMA interfaces. So the CPU is not actually using the system bus. This is called as transparent DMA. Transparent means it is visible, it is known to the processor and known to the DMA controller. The above shown DMA circuit has the following process here. It has 5-step procedure. The first step, the CPU executes two IO instruction which load the DMA transfer to IOAR address register, input output address register, and the DMA controller with the initial values. Now the input output address register should contain the base address of the memory region to be used in the data transfer. DC register should contain the number of words to be transferred from that region. In the step 2, the DMA controller is ready to transmit or receive the data. It asks the DMA request to the CPU. The CPU waits for the next DMA breakpoint. The DMA controller relinquishes the control of the data on the address lines and activates the DMA. Then it acknowledges. The controller is received from the CPU means it will acknowledge. The DMA request and the DMA acknowledge is used for bus request and bus grant. DMA request from several DMA controller are resolved by the bus priority control signal. Now in the step 3, the transfer of data from or to the memory will take place. In the step 4, what happens after it reaches the complete transfer, it finishes the complete transfer, then the DMA request line is deactivated. The CPU responds acknowledge and returns to the system bus. This is the last step called as the DC, that is the DMA controller register is decremented to 0 so that it give the control to the system bus. It completes the transfer, it finishes the transfer here. So it may also send an interrupt request signal to the CPU. The CPU responds by calling the IO device or initiating a new next transfer. So in the 5 steps procedure, the DMA transfer will take place here by DMA acknowledgement and DMA request signal, which is given to the bus request and bus grant to transfer the data. Mainly there are 2 types. What are they? There are 2 types are cycle steal mode and block mode. This is for faster transfer of data. Thank you.